All right, so in this video of notes, we are going to be looking at the quadratic formula. And we're going to break it into two parts. One part is going to be looking at the setup and the logic behind it, and then the other one is going to be looking at the actual solving and simplifying of the quadratic formula. So in our initial one for the setup, make sure you title your notes Quadratic Formula Setup. And the question is, what is it? It is a formula to solve for x when given a quadratic equation, right? That's what it's all about. It's the formula. It says if I am given a quadratic equation, do I factor it? Do I do any other ways of graph it? How do I solve for x? But basically it says you can use this quadratic formula when you are given a quadratic equation. And remember, quadratic equation is when you have x squared for your leading coefficient and your leading term. Excuse me. So standard form of quadratic equation would look something like this. Make sure if you need to pause the video anytime to write this stuff down, please feel free to do so. So a squared plus b squared, or sorry, Pythagorean theorem there, ax squared plus bx plus c equals 0, where a, b, and c are constants. And remember, constants is just a fancy term for numbers. So variables are my x's and my y's, my unknowns. Constants are my a's, my b's, my c's, or that can be plugged in with 1s, 2s, 5s, and my numbers. So an example you might see is something that looks like this. 2x squared plus 3x plus 5 equals 0. And that is kind of a key factor, is that we want to make sure it's equal to 0. If it's not equal to 0, then you want to use the subtraction property of equality or the addition property of equality, whatever need be to kind of get it set equal to 0 and get all your variables and constants on one side. It makes life a lot easier for the situation. So, and let's see in our example, we have our a, which is our 2. We have our b, which is the constant in front of x, so that's a 3. And we have our little constant out here all by itself, which would be my c, and thus is 5. So this part here is essential, being able to identify your constants, because you're going to need that when it comes to the formula. So know what your standard form is, being able to identify your constants, and which letter they represent. So another way you might see it would look something like this. This is still a quadratic equation. We have our leading term here as x squared. But if you notice, there's only 2 terms. And what that means is going to be this here. And these are all important to recognize that they're still using the same standard form for a quadratic equation, and so we can still use the quadratic formula to solve them. So, but in this situation, my c just happens to be 0. So instead of writing it out like this, you can just basically simplify it down to write it like this. So this and this are 2 ways of writing the exact same equation. So it's important to recognize, like, where's c? Oh yeah, c is just 0. So another way that you might see a quadratic equation actually would look like this. Believe it or not, that's still a quadratic equation. We still have our x squared, right? But you're like, well, what is b? What is c? If they're not there, then there's 0. But they still have technically a numerical value. The numerical value is just nothing. It's just 0. So b equals 0 in this situation, and c equals 0. So you could rewrite this equation, which feel free whenever you have these, if you need to, write them out this way first. That way you can then identify your B's and C's a lot easier. That your B is 0 because 0 times anything is 0, and my C was 0. And obviously I can rewrite this entire equation just like this. So this is an important acknowledgement that all three of these still count as quadratic equations. They still have an A, a B, and a C, and thus they can all be rewritten into a quadratic formula if you want to. So if you take this equation here, your standard equation, and solve for x, so there's actually a whole, you can look it up online, there's a whole sheet of math that went in of the process to go through to go from here and start simplifying down to solve for x. And when you do so, that is when you get the quadratic formula. Is the formula that you get to solve for x by just getting everything over to the other side of the equation and isolating x by itself. And that quadratic formula is this. Okay? So of negative b plus or minus the square root, because if we had a square here, we have to have a square root somewhere to be able to undo it. And we have b squared minus 4 times a times c, and all of that is divided by 2 times a. So this is the formula. It's the exact same formula here, but somebody just isolated and solved it for x. And so now if you notice, it's all in terms of a, b, and c, which are all my constants, which allows me to plug in those numbers and figure out how much x is. And that is why you can use the quadratic formula on any quadratic equation to find x. So let's just look at an example. So now you can plug in a, b, and c to find x. So make sure you get that down into your notes. So let's go back to our original example equation that we had at the top. As before, we recognized what a equaled, what b equaled, and what c equaled. So once we take those from the standard formula, I can now start substituting them in to my quadratic formula, the standard equation, and plug them in and solve for x. And so you would get something like this. I plugged 3 in for my b. Notice it's the minus a b, and we'll come up to this later in the next part, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So you plug them in, substitute them in, okay? You can use substitution. Use substitution and get those. And now from there, you can start solving for x. And that's what it's all about, right? So in the next section, we'll look at how to go about to solve for x to make sure you avoid major pitfalls and to get your answers. Page 2, and you have quadratic formulas solving for x. So last part we looked at setting it up, where it came from, what does it look like, how to be able to substitute our numbers, and we're actually now going to go through the steps to be able to solve it and get these into your notes because it's essential. So we have our given equation, which we're just going to use the same one from previously. And the first step, believe it or not, is the process to actually choose to use the quadratic formula. That is the very first thing. You look at a quadratic formula and you can ask yourself, am I going to factor it? Am I going to graph it? Or am I going to use the quadratic formula? So you have those choices to be able to solve. And factoring is pretty common, nice, easy way to do it. But when factoring doesn't seem to be working or doesn't seem to be easy for its setup, then initially that's where you're going to come and use the quadratic formula. So you have to first choose to use it. Once you make that choice of I'm going to solve this using it, or by chance the book or the assignment tells you to use it, then write down the equation. What is the quadratic formula? You have to make sure that you put those two together in the very first step. So if you notice, that's what I did. I wrote it down and have it all set up so I can start using it and simplifying. So my second step is to identify my A, my B, and my C from my original equation. If you remember from standard equation, we had our A here, my B was there, and my C was there. And if you need to, feel free to write that down into your standard form to be able to recognize it. So remember, this is ax squared plus bx plus c equals 0. So that is the form and where we get our A, our B, and our C from. Once we identify our A, our B, and our C from our equation, and we have our formula, then we can substitute in those quantities into the formula. Now this is where it comes the important part of watching for negative numbers. If anytime this happened to be like a -2 here, that's why I kind of put these in parentheses, because this would be minus -2 inside here. Or excuse me, for my A's. Be -2 in my A's, -2 in my A's. If this was a -3, then this would be a -3 inside here. It'd be a -3 inside here. And the same with my C's. So that's why I kind of like put them in parentheses, because it kind of helps to reiterate that concept that you might end up with basically double negatives, or a negative times a negative, and then obviously you need to change the sign. So make sure this negative is still true, the subtraction is still true despite any negative numbers, and the same here. This does not change regardless of the sign of this B. Okay? So when you set it up, that's the very first thing to watch for very common mistakes. So fourth step, okay, is to square. I like to work with the inside. When you start getting to a point, you're welcome to kind of work in your own order or kind of do things simultaneously. But I like to work with the square root first and inside here, and then work my way out. So first we're going to square my B, but remember, you should end up with a positive number. If you do not, then you need to go back to your calculator and most likely put your negative number inside the parentheses. It's very important. If this was a -3, if you do -3 squared in a calculator, they're going to square the 3 first and then apply the times -1. So this number here should always be positive. If not, double check, did you enter it into the calculator correctly by making sure that you had parentheses around it. So that's a very common mistake area there, and one thing you want to look for and make sure you've done correctly. The fifth step is to multiply here. Now again, this is another area where a lot of students have gotten things wrong because they might have had like a -5 here, and then they multiply through and they just keep it as -40 as your answer. But remember, it's minus whatever you get after multiplying your A and your C times the 4. And if that number, after you multiply these three together, is a negative number, then you're still going to subtract it. Okay? So that's why, again, the parentheses are very helpful in keeping track as to those little extra negative signs that can change your entire answer from being correct to being wrong. So whatever you get goes inside, and then you're still going to apply a negative to it. Okay? And if you have a negative inside and negative on the outside, then remember your answer should be a plus answer, and you should be actually adding these two. But since this isn't, and this is a positive 40, 90 minus positive 40 is going to give me, in this situation, a negative answer. Okay, so that's another big area to pay attention to on the fifth step. Okay, so number 6. First off, if after you get through simplifying here, you get a negative number like I have, then know already that you're going to be able to pull that negative sign out by taking the square root of -1, which we write as I. So as soon as you see a negative inside the square root sign, know that you're already going to need to rewrite it with an I and the square root of the positive of that number. Second thing that you want to look at is the number that's inside the square root divisible by a perfect square? And if so, simplify. So if this happened to be, let's say, -36, okay, then you can say, okay, well, the square root of 36 is 6. So I could actually simplify this down to 6i. If it happened to have been, let's say, 72. Remember, 72 can be rewritten as the factors of 2 times 36, of which time I could rewrite as 6 times the square root of 2 and pull out the 6. So that comes back to simplifying your roots. And the big thing is the number that's left in underneath here is it itself square rootable. You can take the square root of it, or is one of its factors a perfect square? Is it divisible by 4, 9, 16, 25, 36? Okay, all the perfect squares. And if so, then simplify. And then that's when you'll get a number on the outside, potentially, and a square root of still some remaining number on the inside. And maybe an I if there's a negative, like in our situation. So if you can, simplify, and then you'll get to this part here of number 7, step 7, where I address the B. And again, when you can do it in technically any order between the radical, the B, and the 2a. This is just the order that I'm working with, is the numerator first before going to the denominator. So negative b was a positive number, and so in that situation I still end up with -3. If it would have been a negative b inside here, then remember you would have ended up with a positive b afterwards. So that's an important reminder in an extra little spot where sometimes people get the wrong answer. 8, okay, is that I have multiplied my denominator, and I'm starting to look for ways to reduce it, to simplify it. And remember, only numbers outside, either here or here, can be simplified by the denominator. So even if this happened to be 8 inside my radical sign, it is untouchable. You cannot simplify it with 4. It is off limits if it's inside the radical sign. Okay? Only numbers that are outside of the radical sign can you simplify with this denominator. And if you can one and not the other, then make sure you keep that one still as a fraction, and however it happens, reduce down. So basically you're looking at, can I simplify these numbers here into a number? Plus or minus, can I simplify these numbers? So if there happened to be a 2 there, then you could write it as 1/2. If there was a 4, then it can simplify down to 1. If it was an 8, you can simplify it down to 2. 8 divided by 4 is 2. This one's off limits. Okay. So things to think about there. Can you simplify it by the denominator? If so, do so. Otherwise, technically, you'd be done. But there is a situation where you wouldn't be finished at this point. Okay? So most of the time, a lot of times, this is where you would end, possibly after simplifying if need be. I can't simplify, so this doesn't simplify any further. Okay? And the time period where you would not be finished is if you had something that looked like this. If you notice, my answer here is, in fact, a perfect square. And since it is a perfect square, that means I can take the square root of it and get a nice whole constant. If that is the situation, then you can go further to simplify this. And you're going to do so, since it's a plus or minus negative, you're going to create 2 equations from here. So that's what my arrow is kind of going off. Equation 1 and equation 2. And those 2 equations is going to be one of them with this number plus this number divided by your denominator. And your other equation is going to be this number minus that number divided by your denominator. So those are your 2 equations that you would create. And then from there, you'd just start simplifying. You'd have the numerator divided by the denominator. Some situations you might get a whole number. You add the numerator, divide by the denominators, and other times you might get a fraction. That is perfectly okay. And then what that means is that x could equal either one of those answers and make the statement true. And then you are finished. All right. So I hope this helped. Make sure you get it all copied down and to keep an eye on classic areas and pitfalls. And I hope this helps.